What's up? I'm back. Second video of the day. Working hard out here, Today, the second problem we're going to be solving is LeetCode 2405, optimal partition of string. So given a string S, partition the string into one or more substrings such that the characters in each substring are unique. That is, no letter appears in a single substring more than once. Return the minimum number of substrings in such a partition. Note that each character should belong exactly to one substring in our partition. Okay, so it's kind of a confusing explanation, but if we go through an example, it's actually a lot simpler, I think. I was trying to figure out this one out beforehand, because I thought it looked a little bit more manageable than I'm just bad at the grid problems right now. I feel like those are, maybe it's just because I don't draw it out enough. Once I drew it out, it was made a lot more sense. So let's take this example. Actually, let's just do an easier. Let's do our own example. So we have A, B, A, C. So that's our string. I like this drawing software a lot more. I think there's some cool looking thing there too. Oh, that's so crazy. Okay. Basically and we're looking for substrings in this, but we're looking at the minimum number of substrings. But each substring has to only contain each character once. And I think it's only lowercase a through z. Yeah, English lowercase letters. So that makes it really nice. There's only 26 of those. Acceptance rate is 80%. It's pretty good. If we go through this, right? Okay, first, so A, that's just, that's it. That's the start of our substring. And, obviously nothing else is going to be in there. We can go, okay, we can also add B, right? That's also in there. That's a different character. Okay, now we go to the next character. Oh, it's A again. Okay, that's not, we can't use that again. A is already in our substring, so this is one substring. So then we start again. We have A, then we go to C. Okay, C is not in our substring. So in this case, we'd have 2. Be our output. That would be our output there. And so the data structure you want to use for this is something called a hash set. And that's something, I think I'd heard of it before. I definitely heard of a set. But a hash set is just like a hash map that has the properties of a set where it can't contain duplicate values, or in this case, duplicate characters. And so how do we do that is we got our hash set equals set function. Or no, I think we just do this. I don't know, we'll see. Then we're going to have our result, and we're going to set that equal to 1. And I'll explain why. So let's delete this. What was that? So an example of why we need it. Let's see if we can explain it with that. I don't know if this case will make it come up. Right, so our result's 0. We're going, okay, A, B, hit A again. Okay, now set our result to 1. Okay, now we have A, C, and then we're done. Maybe I can explain it with this example. All S's. So we start at S, okay. Then we go to the next S, and then we hit the next character, and it's also S. So okay, now we have 1. We increment our result 1. Maybe I'll just try to code it out, and then I'll try to explain. So say for characters in string, if C in hash set So if it's in the hash set, what do we want to do? Yeah, because we're going to have two scenarios. If we hit a character that we can add to the substring and we're not going to increment, or if we hit a character that is in the substring. And that means, okay, we're going to start a new substring. We're going to increment our result. So we'll have else. And I think in the else, we're just incrementing the result, right? Here, we're going to have to set our hash set equal to null. And then we're going to have to append dot. See? That's how you do that. I think my syntax is all kind of screwed up here. Invalid syntax, yeah. So, how to append to a hash set. I don't like it. What? Is it for CMX string? Because, well, we don't. See how to loop through a string. Do you have to do the range like thing? I feel like that's going to give us some good results, though. Object of type. What the heck? Okay, let's see what. Let's see what the folks are, what they're doing. See what everybody's up to. What? Oh. You gotta use a string name. String name of string is not a type. Hashy set. Okay. Oh, and then we have to return at the end here. Return result. I think we also have to. Don't we also have to do it here? Akababa. So we got 8. Interesting. Okay, so we're 1 over there. definitely want to do that first. Okay, so let's go through. Let's go through our example. So let's say, Jesus, that's huge. Let's say we got a string. Let's say we got A, B, A, B, A. So, okay. Hash set's nothing, results 1. Characters, so we're going to start with A. If A is in hash set, it's not. Saying the hash set's nothing. We're appending A, so now we'll do this as our hash set. Right now, that's A, adding 1 to the result. I guess we probably don't want to add 1 to the result. That doesn't make any sense. We're still getting 8. It doesn't change it. Huh. Okay. So now we're appending A to the hash set. Okay. Oh, because A is not in the hash set. So result. Oh, but we're never appending. That's the problem. We need to append here. Tuple object is no attribute append. What? The heck? That's so strange. So he's just using an empty string. Partition string. That's pretty smart. Oh, he's got a set here. Oh, do we have to do it like that? Did I click this guy? And he's doing hash set.add. Tuple object. What? What's going wrong here? For C, if C is incorrect, this is like the same exact solution. So the first time this is a problem, so we'll try not add it. And he didn't have an else statement. Let's try reorganizing all these little thingies. We're still getting 8. Huh. Alright, so if C's in, because we're still going to ping pong. Or C's not in hash set, so it's just going through 1, 2, 3, 4, 5, yeah, 7 card version. It's just like, oh, add. It's not result, add the result, add the result. How did you avoid that? Oh, you flip the 2. So result should be here. Let's cut this. Dang, man. That confused the heck out of me. it's still pending. Wait, what? Wait, I want to see if that would work. See if this still doesn't work. Yeah, let's try reloading. Sometimes it breaks. Can I not use the hash set name? Is that the problem? That might be the problem. Take a special name. Dude, what? What are we doing wrong here? Tuple object. It's a tuple. I think that's just some kind of integer. Yeah. What? This is like the same solution. What's going on here? So yeah, we got our set, count. Oh, that's why. Ah. I was just setting it to whatever parentheses are, probably a list or something. When I set it the second time, but I made it blank. Okay, so yeah. Jeez. Frustrating. So yeah, how this works, we got our hash set our result to 1 for characters in string. C is in our hash set. We're gonna set it, we're gonna make it blank, and it's like, okay, clearly we've started a new substring. Now we add 1 to our result. If it's not else, right? If it's not in the hash set already, we need to add it to the hash set. So that's what it's going to do. So let's go through this one. All right, so we start with A. A is not in the hash set. We add it to the hash set. Start with B. Go to B. B is not in the hash set. We add it to the hash set. Go to A. Okay, A is in the hash set. Our new set. Our old set was AB. Our new set is just going to be nothing. We increment our result by 1. So we have R equals 1. And we started with 1, but we're not. This is like showing why we need to start with 1. Yeah, and then we go back through. Okay, we're at A. We need to add it. Okay, we add it. We go to B. B's not in the hash set. We add it. Okay, we go to A again. A is already in the hash set. We add 1 to our result. But now we're done. So our result's 2. But if you look at this, we can do this. These are our substrings. So we need to account for, okay, we have this extra A over here. So that's why we set our result to 1 at the start. And hopefully this will pass all these tests. It did. Cool. And yeah, because it's a hash set, and we're just incrementing through the string, it should be O of n time. And then the memory complexity, we could have all the strings, or we could have 26 characters total. Like let's say it was just A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. It was like the whole alphabet in a row. That's the biggest thing we could put into our hash set, right? Because it was the whole alphabet, 26 characters. Then we add another A at the end. Breaks it, you know. You add any other character once you get all 26, you know, you're gonna have to start a new hash set. So it can be O of 26 or O of 1. Cool. Thanks, y'all. Bye.